If you interchange any two rows or two columns, then the value of a determinant changes in its sign. If you interchange, that is, if you transpose this determinant, you will get A dash, then the value of A and A dash determinant are found to be same. If all the elements on one side of the principal diagonal are zeros, then the value of a determinant is equal to product of principal diagonal elements. Since all the elements in the third column are 1, 1, 1, suppose if you add this x plus y plus z, y plus z plus x, z plus x plus y, you will get x plus y plus z. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss regarding very important concept, that is regarding properties of determinants and the problems based on that, and also finding the adjoint. So, whatever the questions asked in the examination for 3 marks and 5 marks, that I am going to discuss in this session. First one, properties of determinants. So, usually you may expect one question from these properties of determinants for 3 marks. Now, there are so many properties. Let me explain few important properties. The first one, the value of a determinant remains unchanged if its rows and columns are interchanged. The value of a determinant remains the same. The value of a determinant is not altered whenever its rows and columns are interchanged. That means, suppose if A is a determinant, then the value of determinant A and A dash are same. If you interchange, that is, if you transpose this determinant, you will get A dash, then the value of A and A dash determinant are found to be same. Now, let us take an example. Let me explain with this. Now, let us come to the proof. Now, what is the proof for this? Let us consider delta is equal to a 3 rows 3 column determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Now, then transpose this delta dash is equal to interchanging the rows to column. So, first row becomes first column A1, A2, A3, and the second row is B1, B2, B3 becomes second column, and the third row C1, C2, C3 can be written as third column C1, C2 and C3. Now, what is to prove? To prove that delta dash is equal to delta. That means the value of determinant delta and the delta dash are found to be same. Let us expand first delta. Now, expansion of this delta is equal to, now you know, plus, minus and plus. How to expand a 3 rows 3 column determinant with respect to first row? Expand with respect to first row, plus, minus and plus A1 into this row column is deleted, multiply B2 C3 minus C2 B3, again minus A2 into this row and column is deleted, B1 C3 minus C1 B3, then plus A3 into this row and column is deleted, B1 C2 minus C1 B2. Now, simplify this. This can be written as multiplied A1 B2 C3 minus A1 B3 C2, again minus A2 B1 C3, minus into minus plus A2 B3 C1, again lost A3 into B1 C2 can be written as plus A3 B1 C2, again minus A3 B2 and C1. Now, let us represent this as equation number 1. So, this is the value of delta. So, the value of delta is equal to this much. Now, move on to the second part. On the other hand, now let us simplify this. Delta dash is equal to, what is delta dash? That is A1, A2, A3, B1, B2, B3, C1, C2, C3. Expand this. So, after expansion, what we are going to get? This is A1 into B2 C3 minus B3 C2 minus B1 into this row and column is deleted, A2 C3 minus B1 into this row column is gone, A2 C3 minus A3 C2, again plus C1 into this row and column is gone, A2 B3 minus A3 B2. Now, multiply this. This is equal to A1 B2 C3 minus A1 B3 C2, again minus B1 A2 C3, minus into minus plus A3 B1 C2 plus A2 B3 C1 minus A3, B2 and C1. Let us represent this as equation number 2. So, just verify equation 1 and 2. What is equation number 1 and 2? See here, plus A1 B2 C3 plus A1 B2 C3 minus A1 B3 C2 minus A1 B2 C3, and the last element is plus A3 B2 C1 A3 B2. So, what do you say from these two? If from 1 and 2 we can say that LHS is equal to RHS. Therefore, from 1 and 2, therefore delta dash is equal to delta. The value of a determinant will remain the same whenever its rows and columns are interchanged. Very important property. Okay, followed. So, just expand first and interchange the rows to column and expand. LHS and RHS are found to be same, which means delta dash is equal to that means the value of a determinant will remain the same whenever its rows and columns are interchanged, right. Now, move on to the next property. Let us take, what is the property? If any two rows or columns of a determinant are interchanged, then the sign of a determinant changes. So, if you interchange any two rows or two columns, then the value of a determinant changes in its sign. So, that is, let us consider delta is equal to A1, A2, A3, B1, B2, B3, C1 and C2. Now, interchanging the rows, let us interchange this. Interchanging R1 and R2, interchanging row 1 and row 2, then this can be written as delta 1 is equal to interchanging this. So, first row this is R1, R2, R3. Let us change row 2 to row 1, B1, B2, B3. Then this is A1, A2, A3. So, this is C1, C2, C3 as it is. Now, let us expand this. Plus, minus and plus as usual. A1 into B2 C3 minus C2 B3 minus A2 into this row and column is deleted, B1 C3 B1 C3 minus C1 B3, then plus A3 into this row and column is gone, B1 C2 B1 C2 minus C1 B2. Simplify this. This is A1 B2 C3 minus A1 B3 C2 minus A2 B1 C3. Again, minus into minus plus, it is A2 B3 C1. Again, plus A3 B1 C2. Again, plus into minus minus A3 B2 C1 B2 C1. Let us represent this as equation number 1. Now, let us expand this. Plus, minus and plus. This is equal to B1 into this row and column is gone, A2 C3, A2 C3 minus C2 A3 minus B2 into this row and column is deleted, A1 C3, A1 C3 minus C1 A3, C1 A3, then last plus B3 into this row column is gone, A1 C2, A1 C2 minus C1 A2. Simplify this. If you multiply this, what you are going to get? I will write here. That's equal to B1 A2 B1 C3 A2 B1 C3 minus A3 B1 C2 A3 B1 C2. Again minus A1 B2 C3 A1 B2 C3 minus into minus plus, it is A3 B2 A3 B2 and C1 A3 B2 C1. Next last plus A1 B3 C2 A1 B3 C2 minus A2 B3 minus A2 B3 and C1. Let us represent this as equation number 2. Now verify equation number 1 and 2. See here in equation number 1 plus A1 B2 C3, it is plus, here it is minus A1 B2 C3, it is minus. Again if it is minus A1 B3 C2 minus A1 B3 C2, here it is plus. If it is minus means it is plus. So here in equation number 1 we have plus, whereas in equation number 2 we have minus. So that means from 1 and 2 we can say that, therefore from 1 and 2 we can say that from 1 and 2 we can say that delta dash is equal to minus delta, that or delta is equal to minus delta dash. So that means the value of a determinant changes in its sign whenever its two rows and two columns are interchanged. So if you interchange any two rows to column, then the value of a determinant changes in its sign. This is how we are going to verify. Very important property for 3 marks. Now move on to the next problem. Now, so there are so many properties, like suppose if all the elements in a row or column are zeros, then the value of a determinant is equal to 0. Or suppose if any two rows, two columns are identical, then the value of a determinant is 0. If all the elements on one side of the principal diagonal are zeros, then the value of a determinant is equal to product of principal diagonal elements. Similarly, if all the elements in a row or column are zeros, then the value of a determinant is equal to 0. So like that, there are so many properties. Let me take some problems based on these properties. Now what are the problems? So usually you may expect this type of questions for 4 marks. In a part E, you will expect one 4-mark question, that is question B for 4 marks. Now what is the problem given? To prove that the value of determinant is equal to 0. Now to prove that this determinant is equal to 0. Now write down this given determinant. Now what is given? This is given determinant. Now this given determinant is x plus y, z1, y plus z, x1, z plus x, y and 1. Now since all the elements in the third column are 1, 1, 1, suppose if you add this x plus y plus z, y plus z plus x, z plus x plus y, you will get x plus y plus z. You can take x plus y plus z common factor and you will get the answer. Now this is nothing but, as usually you know, this is R1, R2 and R3. This is column 1, column 2 and column 3, right, column 3. So convert this row as 1, 1, 1, so you will get the answer. Now let us take it. R1 dash is equal to R1 plus R2, R1 plus R2, R1 plus R2, that is, so second row is same, Z, X, Y, 1, 1, 1, third row is also same, second and third row are same. So R1 dash is equal to R1 plus R2, X plus Y plus Z, this is x plus y plus z. Again y plus z plus x is nothing but x plus y plus z. Again z plus x plus y is nothing but x plus y plus z. So in the first row we have x plus y plus z, x plus y plus z, x plus y plus z. You can take x plus y plus z common factor, x plus y plus z common factor out, 1, 1, 1, z, x, y, 1, 1, 1. So according to the property, if two rows and two columns are same, if two rows, two columns are same, then the value of a determinant is 0. This is into 0 because two rows are same. X plus y plus z into 0 is equal to 0, which is the required answer. So if you want, you can write the because two rows are same. Two rows are same. If two rows, two columns are same, then the value of a determinant is 0. This is x plus y plus z is into 0 is equal to 0, which is the required answer. Now this is 4 marks question. Now move on to the next problem. So prove that 1ABC, 1BCA, 1CAB is equal to A minus B, B minus C and C minus A. Now let us take LHS 1, 1, 1, A, B, C, this is BC, CA and AB. Now let us convert, taking R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R2. So this can be written as, first is same 1A BC as it is, 1 minus 1 0, B minus A and CA minus BC. Again this minus this, 1 this minus these two. So R3 dash is equal to R3 minus R2, 1 minus 1 is 0, C minus B and AB minus CA. Now this can also be written as here 1A and BC as it is determinant. So here 0, B minus A. You can take the common factor, C is a common factor, then this can be written as A minus B. This is 0, C minus B. Here you can take the common factor as A is a common factor, then you can write B minus C. So this can be written as here 1A BC as it is. Now in the second row you can take the common factor as A minus B. You can take A minus B as the common factor. So then this becomes 0. B minus A, if you take B minus A can also be written as minus of A minus B. Then this becomes minus 1 and here it is plus C. And here also you can take a B minus C common factor. If you take b minus c, then this is 0. C minus b is also equal to minus of b minus c, and b minus c is gone a. Now, suppose if as I told, if all the elements on one side of the principal diagonal are 0, then the value of a determinant is 0. If all the elements below the principal diagonal are 0, then the value of a determinant is equal to product of the principal diagonal elements, 1 into 1 into 1. Now, convert this minus as 0. For this, you can take the property R3 dash is equal to R3 minus R2. Now, this can also be written as, I'll write here, this is equal to a minus b as it is, b minus c as it is, and determinant. So, 1, a, b, c same, 0, minus 1, c as it is. Now, 0 minus 0 is 0, minus 1 minus into minus plus, minus 1 plus 1 is 0, then you will get a minus c. Since all the elements on one side of the principal diagonal are 0, then this is a minus b into b minus c into, just multiply 1 into minus 1 into a minus c. This is a minus b into b minus c is minus of a minus c. This can be written as a minus b, b minus c, minus of this can be written as c minus a, which is the required answer. So, the answer is a minus b, b minus c, and c minus a. This is how we are going to simplify. That's it. Just very simple concept. The intention is to convert all the elements below the principal diagonal as zeros. That's all. So, take R2 dash is equal to R2 minus R1, and R3 dash is equal to R3 minus R2. So, 1 minus 1 is 0, b minus a, ca minus bc. This minus this, 1 minus 1 is 0, c minus b, ab minus ca. So, here you can take the common factor c, and here the common factor a minus b is the common factor. So, in this a minus b is a common factor in the second row, a minus b is gone, b minus a can also be written as minus of a minus b, then minus 1 c, again b minus c common factor, c minus b can also be written as minus of b minus c, then this becomes minus 1 and a. Convert this minus 1 as 0. For this, subtract R2 dash is equal to R3 minus R2. So, 0 minus 0, minus 1 minus into minus plus 0, a minus c. So, since all the elements below the principal diagonal are 0, then this is equal to 1 into minus 1 into a minus c. Minus of a minus c is also equal to plus c minus a, which is the required answer. Hope you followed. These are few problems. So, you may expect this type of questions for 4 marks in your part E. Now, let me take one more problem like this. Prove that x, y, z, a, b, c, x plus a, y plus b, z plus c is equal to 0. See here, if you add these two, what you will get? X plus a, y plus b, z plus c. X plus a, y plus b, z plus c, you can take the common. So, two rows are same. If two rows or two columns are identical, then the value of a determinant is 0. Now, let us move on to this. Take LHS, x, y, z, a, b, c, x plus a, y plus b, z plus c. Now, just add these two, that is adding C1 dash is equal to C1 plus C2. This can be written as C1 dash, we are going to change. This column A, B, C, second column is same, and the third column x plus A, y plus b, z plus c is also same. Now, add these two, x first elements. So, C1 column number 1, x plus A, then y plus b, then z plus c. We are adding this. See here, just very simple step. Taking C1 dash is equal to C1 plus C2, A, B, C, C2 same, C3 is also same, and the C1 x plus a, y plus b, z plus c, x plus a, y plus b, z plus c. These two columns are same. Since two columns are same, two columns are identical, same. Therefore, the value of determinant is equal to 0, which is RHS, because this C1 and C2 are same. Therefore, these two columns are same, then the value of a determinant is equal to 0. According to the property, if two rows and two columns are same, then the value of a determinant is equal to 0. Now, move on to the next problem. Prove that 1, 1, 1, a, b, c, a square, b square, c square is equal to a minus b into c minus a minus b, b minus c into c minus of a. Now, let us take LHS 1, 1, 1, a, b, c, a square, b square, c square. Now, let us take LHS. R2 dash is equal to R2 minus R1. Subtract these two. Similarly, R3 dash is equal to R3 minus R1. This minus this. So what we are going to get? 1a square as it is, 1 minus 1 0, b minus a, b square minus a square. Similarly, r3 dash is equal to, what is r3 dash? r3 minus r1, 1 minus 1 0, c minus a it is, then c square minus a square. Now, this can also be written as, this is 1 0 0, a, b minus a, c minus a as it is, right. You know, a square minus b square is equal to a plus b into a minus b. Similarly, b square minus a square can be written as b plus a into b minus a. C square minus a square is c plus a into c minus a. Now, just remove the common factor. See, what is the common factor here? 1 a square as it is. In the second row, we have b minus a is the common factor, 0, 1, and you will have b plus a. Similarly, c minus a is the common factor. So, 0, 1 and c plus a. Now, convert this 1 as 0. For that, take r3 dash is equal to r3 minus r2. b minus a into c minus a. This 1a square, this 0, 1, b plus a as it is, 0 minus 0, 0, 1 minus 0 is 0, subtract this, c plus a minus b minus a. Minus a plus a gets cancelled, c minus b. Since all the elements below the principal diagonal are zeros, therefore its value is equal to b minus a into c minus a into 1 into 1 into c minus b. Now, what is to write? B minus a is also equal to minus of a minus b into, so c minus b is also equal to minus of b minus c into this c minus a as it is, minus into minus plus, this can be written as a minus b into b minus c into c minus a, which is a required RHS. That's it. So, what is the RHS? A minus b, b minus c and c minus a, that's it. So, this is how we are going to solve. So, these are all very important type problems for 4 marks, sure questions. Now, hope you got an idea how to solve these type of problems. Now, move on to the next concept. You might have been studied regarding cofactors and adjoint. Let us take a problem based on adjoint of a square matrix. So, what is adjoint of a square matrix? The adjoint of a square matrix is nothing but the transpose of the given matrix. See, if C is a cofactor matrix, then the transpose of the cofactor matrix is called the adjoint, denoted as C dash is equal to ADJ, adjoint of A. Now, here what is the problem given? A is equal to 1, 2, 3, 4. Show that A into adjoint of A is equal to, adjoint of A into A is always equal to determinant of A into I. Now, first find out the value of determinant A. What is determinant of A? Determinant of A is 1, 2, 3, 4. This is 4 ones of 4 minus 6, this is equal to minus 2. Determinant of A is equal to minus 2. Now, find out the adjoint. You know, adjoint for 2 rows 2 column can be easily written as interchanging the diagonals. 1 4 can be written as 4 1 1, and changing the signs for the secondary diagonal elements. Plus 2 becomes minus 2 and plus 3 becomes minus 3. That's all. This is the adjoint. Interchanging the diagonals, 1 4 can be written as 4 and 1, minus 2 and minus 3. Now, let us take LHS. LHS, A into adjoint of A. So, what is this equal to? A is 1, 2, 3, 4, and the adjoint of this is 4, minus 2, minus 3 and 1. Simplify this. First row, first column, matrix multiplication. First row, first column, 1 4s are 4, again minus 2 3s are 6, 1 2s are 2, plus 2 1s are 2, again 3 4s are 12, minus 3 4s are 12, again 3 2s are 6, plus 4 1s are 4. This is equal to, what is this equal to? 4 minus 6 is minus 2, 0, 12 minus 2 is 0, minus 6 plus 4 is minus 2, right. This can also be written as minus 2 times 1 0 0 1. What is this equal to? Minus 2 into 1 0 0 1 is I. What is this minus 2? Since determinant of A is equal to minus 2. So, therefore, this can be written as determinant of A into I. First part is finished. Now, move on to the second part. What is the second part? To prove that adjoint of A. Adjoint of A into A is also equal to determinant of. So, you will get the same answer, minus 2 0 0 minus 2. Verify this. What is adjoint of A? Adjoint of A is 4 minus 2 minus 3 1 into A. What is A? 1, 2, 3, 4. So first row, first column, second column. This is equal to 4 ones are 4, minus 3 twos are 6, 4 twos are 8, minus 2 fours are 8. Again, minus 1 threes are 3, plus 3 ones are 3, 3 twos are 6, plus 4. This is equal to 4 minus 6 is minus 2, 0, 0, minus 2. What is this equal to? Minus 2 into 1, 0, 0, 1. That is minus 2 into I. Since what is minus 2? Minus 2 is nothing but determinant of A. So this is determinant of A into I. Now what do you say from these two? So from 1 and 2, let us represent this as 1 and this as 2. From 1 and 2 we can say that therefore A into adjoint of A is also equal to adjoint of A into A is always equal to determinant of A into I. A matrix into adjoint is always equal to determinant of A into I. This is how we are going to verify. This is also a very important problem for a 4 marks. You can also expect this type of questions. These are few problems for a 3 marks and a 4 marks based on the properties of determinants and the adjoint of the matrix. So these are few concepts regarding the properties of determinants and the examples and the adjoint. So that's all regarding today's session. Let us meet with different concepts in the next class. Thank you. Thank you very much.